Hello, and welcome to Wintellect Now presents Get Started with Angular and ASP.NET Core. My name is Jeff Fritz. You can contact me using the information you see there on the slide. Let's take a look at our agenda for this course. We're going to start off introducing the architecture of our sample project. We're going to see exactly how we can use Angular front-end technology, JavaScript technologies, with ASP.NET Core to generate and do server-side operations. We're going to introduce our ASP.NET Core services by building a base project and then building an API that we will connect to from the web. And then we'll take a quick 10 minutes and introduce TypeScript and get you everything you need to know so that you can be fluent quickly with TypeScript. It's a lot easier than you might think. And then we're going to introduce the Angular CLI. That's the command line interface. This is going to help make setting up and managing our Angular project a heck of a lot easier. And we'll show a side-by-side project architecture where our Angular application lives next to our ASP.NET Core application during development and then merges together as we deploy for production. Finally, I'll show you an integrated Angular and ASP.NET Core project type that you might find a heck of a lot easier to use and you can get started with right away. Let's take a look at the architecture of how we're going to build our application. We're of course going to be delivering content over the web to a browser, and we're going to be delivering that from a server, and our server is going to run ASP.NET Core. And ASP.NET Core has features like routing and an API controller to manage machine-to-machine data connections. It also has security features that we can enable to restrict access to certain resources. And of course, we have rich database access that we can use from ASP.NET Core. On the browser, we're going to set up an Angular application. And that Angular application, well, that has routing too. Those routing features will allow us to do a lot of work to present alternate user interfaces to navigate around our application, all client-side. And then we have user interface components, UI components, that we can build in reference and deliver to our browser so that they can load these up and have a very responsive, interactive experience. We're going to build templates for those UI components that will be filled out with our data that will be loaded and presented to the browser. And finally, there's services. Services are blocks of JavaScript that define how to interact with different pieces of the application. The services are created and managed for us in memory by the Angular framework. We're going to use Angular to connect to our ASP.NET Core services using the HTTP protocol. Let's configure our base web project with ASP.NET Core and specify our first API controller that'll start to serve and interact with data for us. All right, let's get started with building a basic ASP.NET Core application to serve an API. In this case, we're going to have a collection of hats that we're going to be serving and interacting with. So I will start with a new project. I'll choose ASP.NET Core web application. I'll put this in my dev folder, and I will call this my Wintellect hat collection. I'm going to be creating an API, so let's create a web API. I'll say OK to that. And in just a second, my application is here. I'll close that. And let's start off defining what a hat is. So I'll create a new folder. I'll call this models. And I will add a new class. There we go. And I'll just call it hat. All right. I'm going to give it just a few properties just so it's rounded out and kind of makes sense. I'll declare an ID, a name, and I'll also hang a count off of it. How many of those do I have in my collection? And then let's add a color. All right. You know what? By default, let's set that count equals 1. Let's go over to our controllers, and by default I have a values controller here. I don't want to be serving values. I want to be serving hats. So let's rename this. I'll use the F2 refactoring and rename this to hats controller. Well, let's rename the file. There we go. So let's make sure we're returning and interacting with hats here. So let's start off by allocating a simple in-memory list for our collection of hats. Now, if you were writing this for a real project, you're probably going to connect to a database or something to go fetch and interact with your actual objects. I don't want to get into database connectivity, those types of things as part of this. You certainly know how to connect to and work with the database. Now let's make sure these methods are actually interacting with our collection there. And post, of course, adds in this case, a hat to my collection. So you would normally do a check here to make sure that you can actually add this, that the value is appropriate. You'd validate it. I'm just going to add it for this. So this is doing an update. So let's see if we can find the hat that was requested. And we're going to do basically the same thing down here in our delete. So we have a simple API to interact with our hat objects. That's pretty easy to see and understand here. Let me start this up and let's just see what happens when we navigate to our hats API. So I zoomed in here a little bit and you could see this is a JSON formatter I have installed inside of Firefox, but you can see I've returned 3 objects and each one has an ID, name, count, and color. Pretty easy to see and understand there, but I've got a simple API now that is returning a collection of hats when I request them. All right, let's go back to our slides and let's learn a little bit about TypeScript. All right, now we need to learn a little bit about TypeScript. TypeScript is the language that we're going to use to program against the Angular frameworks. TypeScript is actually a super language on top of JavaScript. So all JavaScript is actually valid TypeScript, and TypeScript compiles down to JavaScript. This way, browsers don't have to learn a new language. They can continue to learn and work with JavaScript, and we can program with all the features of TypeScript and get rich, effective JavaScript coming out the other side. So TypeScript is called TypeScript because it provides static typing for JavaScript. Right? JavaScript is typically a dynamic language with var objects that are created and you can extend and easily change as you're writing your code. But in TypeScript, all of our types are static. This also provides us a sanity check to ensure that we're using the APIs in large applications correctly. You don't have to check to make sure that you have a property on the object that you're trying to interact with. It just is there because it's of the type you requested. And TypeScript actually looks and feels a lot like C#. Well, that's because both C# and TypeScript were created by the same author. All right, enough talking about a little bit of the theory and introducing TypeScript. Let's actually look at configuring TypeScript processing for our project so that we can start writing some code and getting JavaScript out the other side. All right, let's get started with TypeScript in Visual Studio. I can very easily introduce a TypeScript file into my project by going to Add New Item. I can search for TypeScript, and I can add new TypeScript file, and let's just call this test.ts. And now I'm greeted by the empty canvas. How do I get started? What do I do to write a TypeScript file? Well, in TypeScript, our objects are wrapped up as classes, just like they are inside of C#. And we export our classes so they're available outside the text file that they're written in. So let's start off exporting a class. that we'll just call test class to get things started. And we surround our class definition with curly braces. And with just that syntax, actually, we have a test class object. The compiler knows what it is, and it's available to me. That's pretty cool. But this needs to compile to JavaScript, and as I save my file there, you'll see I still have just this TypeScript file here, and there's no JavaScript coming out. We need to add a configuration file to our project in order for this to start outputting and transpiling to TypeScript. So we'll go grab the TypeScript JSON configuration file and add that to our project. So we've added tsconfig.json, and without making any changes to this file, you can see test.ts now has an arrow next to it, and you can see it's generating a JavaScript file. And look at that, that kind of looks familiar compared to our TypeScript file. And it's created a mapping file that will pass along information so that JavaScript debuggers can interact with TypeScript. But let's look at this JavaScript file, and I'm actually going to pin this here. And let's put this side by side with our TypeScript, because I'd like you to be able to see how the JavaScript changes as I begin to add features to my test class. So I can start off, I can even define, I can start off by defining a method in here. Let's just define a simple hello method. And if we just log something to the console, hello world, save that, and my JavaScript file doesn't actually update over here. Inside of tsconfig.json, we actually have a setting that we can turn on to say compile on save. And now if I come back to test.ts, and now it's going to indicate that there are changes here. And we're going to say yes to all. And now we can see our console log is written here. And we've got test class prototype hello, and it's defined a function. So that's actually some nice JavaScript that it's generating. It's nice idiomatic JavaScript that we can always rely on working in any browser. And we can even start to begin defining properties on this. So we can define something like a name, and we can specify that that's of type string. And as I save, nothing is rebuilt in my JavaScript because nothing's actually assigned and works with this name property. I could say test.name equals Jeff, save that, and you could see over here test.name equals Jeff. Because we don't really need to define a property on our test class if it's not actually being used or consumed by something that needs to have a physical variable sitting there. To go further, I can define a constructor for my class by actually using the word constructor. And I can receive arguments here and have a suffix of the appropriate type of that argument. Now if I save this, you see I've actually got a red squiggly here showing me parameters are required and not provided. So let's indicate that our new test class, and let's use Scott. We'll save that, and my test class now, it actually is passing that in, and you can see I've allocated, and it's already allocated a name argument up here, and it's putting into a this.name variable. So it is hanging a name property off of the test class, but it's not exposed for folks to be able to get to. Let's just go a little bit further here. I can take this bit right here, and I can remove that, and I can still do things like concatenate together my JavaScript, and I can actually refer to the name here because that private value is being returned. Or I could change this, and instead of having it be that name, I can actually refer to this one, and it doesn't know what that is, I can actually refer to it with that syntax, and it'll find it and make it available. So there's all kinds of things we can do with TypeScript. It's normal JavaScript that's sitting here that we can use. Check this out. If I were to copy this code and just paste it into my TS file and save that, I don't get any errors here, and it outputs the exact same thing over here. Actually, it doesn't know what exports is. We just say test class, and it just works. So all JavaScript is valid TypeScript. Now, if I go over to my TS-JSON, this no implicit any will warn if there are any declarations that don't have a type specified. So if I flip this to true and come back over to my test TS, and let's save that, you can see here I'm starting to get errors. The parameter name implicitly has a type, so we need to start forcing types on these. So that passes. And what do we have is a problem here. So test class is an any type. So we need to turn that around and turn this into a class that will actually return and interact appropriately as a type. So TypeScript is very valuable, and you can use it to check to make sure that you have valid JavaScript. But TypeScript is very handy as we start building larger Angular applications, and we'll see that as we move into our next section where we're going to start discussing the Angular framework. So Angular, you can learn more about Angular at angular.io. We know Angular is a JavaScript application framework, and it's comprised of modules, components, templates, metadata. There's data binding features. There are directives, right? Directives are capabilities that allow us to swap out what looks like a tag with a set of functionality. And services. Services is a block of JavaScript code that's wrapped up into a function that we can use to communicate with a server or some other resource. And of course, we now have dependency injection on the client side. And that sounds kind of weird, dependency injection on the client, if you're familiar with using it on the server. But this allows us to keep all of our JavaScript and TypeScript loosely coupled so that we can easily compile together those objects that we need with their composed references at request time. Okay, let's go take a look now at how we can get started with the Angular command line interface, where we get that, how we get it set up on our machine, and then let's set up an Angular project next to our ASP.NET Core project so we can have Angular talk to our web project. This is actually pretty easy to set up and get running. And then finally, we'll take a look at integrating Angular with the ASP.NET Core project model in a different way so that we actually have Angular running on the server and on the client. All right, let's go over to that demo. Okay, I've opened the command line window here for us to start working with the Angular command line tool. Now, in order for us to get the Angular command line tool, we need to have a couple prerequisites met. We need to be running Node 6.9 or higher and NPM 3 or higher, NPM the Node Package Manager. When we have that, we can install the Angular CLI, the command line interface, by executing npm install -g, install it globally, at Angular CLI. And this will take a few minutes to go through and do its complete install process. All right, there it is. It's installed, and it's got some not compatible things because I'm running on Windows and some file system objects are made available for Linux operating systems. So let's clear this, and I can build my first Angular application from the CLI by using the ng command. If I just press enter, it's going to show me a list of command options that I can chain on to that to start building and working with application. And there's a lot of commands that or echoed to the screen for me there. So there are a ton of different things you can do to build an application. And gosh, I can't even scroll high enough to see them all. But we're going to get started with ng new, and we will call this Wintellect ng. Now it's going to create a folder on disk. It's going to start putting all these files that I need in order to get started with this Angular project inside of that folder. It's also going to do an npm restore and bring back all these packages and files that I need to build with Angular. That's going to take a little bit of time here. So I'm going to fast forward the video here a little bit to when this is done installing. All right, it finished installing, and it took a long time to install all the Node packages that are out there. Let's take a look at what's in this folder. So there's a couple of configuration items here. There's a git ignore file because we're actually sitting on top of a Git repository. See, it's on a Git repository. And there's actually a source folder here. Let's take a look at that. And there's an app folder here. If we take a look at that, there's some files, some TypeScript files, some HTML files. Let me go down into assets. There's a git keep. Okay. Something there. Let me go back up one more and look at this again. So I have some TypeScript configuration. I have a TypeScript configuration file sitting here, just like we saw in our example in Visual Studio. And there's also a Node modules folder here. Take a look at what's under the Node modules folder. There's more than 750 packages that are installed in order to make Angular go. All right. Now there's a bunch of test modules that are in here also, but this is not lightweight. This is a lot of content here that you're going to be building and working with. So we can actually get started serving our application by just typing ng serve. And you can see it's building the modules. It's compiling all the JavaScript and TypeScript together, making it available so that we can navigate to this. And it's going to start up a development server on localhost 4200 by default. And now it's running. You can see it used Webpack to compile up all of those packages into 5 files. And here's my project. If we take a look at the source code to this, you can see that AppWorks isn't actually sitting here. It's coming in as a result of these script files here. And these script files were added to the end as part of the Webpack process to make sure this was available to me. But look at this right here. AppRoot. Gosh, that's not a tag that I'm used to from HTML5. Where did that come from? Let's take a look back in our directory. And I'll stop this. I'm going to bring up Visual Studio Code for this folder so that we can tell the difference between our ASP.NET application and our Angular application. I'll keep these two separate. So when I browsed to my application, it actually opened inside the source folder the index.html. And I received this content, and there's my app root with the loading. And notice it doesn't have underneath of it all of those script files that we saw that were returned in my browser. Here. These were placed there by Webpack, which is run when we run the ng serve. So AppRoot is actually available here under our app folder, and everything starts from the app module inside of the Angular application. And we've got an app component that it's bringing in, and it's going to bootstrap that app component when this ng module starts. So let's take a look at what's in app component. So this is app component. It defines a component with this @component syntax. And this is a decorator. This is just like our C# attribute on top of our class that's being exported here that has one property, title, and app works. So this component attribute is defined inside the Angular core framework. Now that's being included and made available to us so we can use this import statement just like we would use a using statement in C# to make that component object available to us. And then we use this at syntax in order to use it just like an attribute. We're passing in these three parameters. Selector is app root. That's the name of the tag that we're going to apply this component to. So back in index.html, here's app root. We're going to replace that with the output of this component. And this component has a template URL. So there's actually some HTML that we're going to use to mash up with this JavaScript, mash up with this TypeScript and its resultant JavaScript after it gets compiled so that we get our actual application. So take a look. Here's our HTML. It's an H1 with that title being output. And the title included in the double curly braces, sometimes those are called mustache, but in the double curly brace says, go find this property and output it here from my component. So my component class defines a title, app works, and it gets mashed up and it drops it right there in between our H1s, just like we saw in our browser. There it is. So that's pretty easy to understand. Now, it said here, style URLs app component CSS. Well, if we take a look at that, there's nothing in here, but we can put information in here about how we'd like our application to style the content coming out of this component. So I can do something like H1, text decoration, underline. I'll save that. Let me go back over to my console window here, and let me try serving the code again. All right, it's done building. I'll go back to my browser. It says it's loading, and now it's underlined. But it's only underlined for this component. So I'll bring up the developer tools here, and I'll click reload so we can get the fresh copy of our JavaScript. We can look at, here's our HTML. When it fetched that initial page, if we look at the response, it's just returning the loading with the app root. If I look at the JavaScript that came back, look at all these things that came back with it. If I click this one, info, you can see it just brought back some information about the current state of the server. So that's interesting. It didn't come back in any new content that we can see here. Let me go over and let's inspect the current state of the HTML. If we look at this object, you'll see it's an H1 ng content C0. So we've got this indicator on that H1. And there's a style block that was created and included here that's an H1 looking for an attribute called ng-content-C0. So this one is the only one that it'll match, and it sets my text decoration underline. Now, while the server is still running here, I can go back over to my CSS, and I can add other things to this, like color equals blue. I'll save that. And if I look at my console here, you can see it did a real quick recompile and it's running again successfully. And I didn't refresh my browser. It's just updated and it's painted blue. It still has my ng-content C0 here. And if I look at the head and I look at the style, it's still bringing over and it's been extended to include that information. There was no additional network hit here. My main bundle and my info, I got a 200. It found new content there that it reloaded. And my WebSocket connection is being kept alive and is forcing the browser to know when there's a change so it can refresh. So this gives us a nice working order where I can be building and writing components for my Angular code and then having my browser automatically update with that new content. This gives us a little bit of a side-by-side model for our application. If I go back over and kill my server, I'm building my Angular application in a folder separate from where my ASP.NET Core application lives, because my ASP.NET Core application lives in this Wintellect hat collection project. And really, I like to get the results of all the things that I'm compiling down into my www root folder over here. So what you can do, let me go back over to VS Code, is I can go into this Angular CLI JSON. And this is the configuration information that defines how the project is going to be compiled and where the assets are going to live when they're built. And instead of delivering to this dist folder, I can actually publish the results to my Wintellect and then www root. There we go. Now I can go back over to my console window, and if I execute ng build, it's gone and built the files just like it had before, and I can roll back over to Visual Studio, and I can see there's a www root folder here. I'll open that up, and now it contains the output of my Angular application. Let me go down to Startup and make sure that I'm still echoing. I'm not serving static files. We need to serve static files in order for index.html and my JavaScript to be served here. So let's make sure that's added to the application. And we need to make sure that that static files method is included. So I'm going to edit my CSproj file and add a reference to make sure that the static files capability is added to my application. And that'll restore that package. And I'll execute a control period here to make sure that we include our using statement appropriately. So now if I run my application, I should get that same result that I had when I ran from my Angular command line. So this by default when I loaded is going to API/values. If I change that to API hats, I still get my collection of hats. And if I go to the root of the application, I get nothing. If I go to index.html, I get the content of my application. It loads up all of my Angular assets, and it shows me the title just like I had it before. Now this is a very separated structure. This is really driving at almost two separate applications how we're building things. And that might be okay for you. There are folks who actually in Visual Studio will add the application from Angular as a second project next to their ASP.NET Core application and allow those two to refer to each other. And that's okay. You can do that. But let me show you a new technique that Microsoft has put together that will allow you to embed Node.js inside of your ASP.NET Core application and execute all your JavaScript server side so that the first request that comes into your server is served as plain HTML, completely rendered, and then Angular can take over on the client side. So I'll go back to my command line and I'll introduce some new templates for ASP.NET Core by executing .NET new -- install Microsoft ASP.NET Core SPA templates star. This will install a package that has a bunch of templates for typical SPA frameworks that you can use on your application. So that finished. And now if I execute .NET new, it's going to show me I have a bunch of new templates that are available to me here. MVC ASP.NET Core with Angular. Look at that. So we can build a new application with Angular tied directly into ASP.NET Core. So let's do that. .NET New, Angular, and I'll specify the name of my application by giving it the -name argument, and we'll call this Wintellect Angular. All right, so let's take a look at what's in that folder. So this looks a little bit like what we had before. I've got a tsconfig in here, Webpack configuration, a dub root folder, controllers, views, and I've got a client app. Let's open this in Visual Studio and dig into it a little bit. It's still loading some packages in the background, but we can see here it looks very similar to what we had before. If I look in my startup class, we start to see where things get a little bit different when we come down into our configure method. Now, use Webpack dev middleware. Hot module replacement equals true. Hot module replacement is what we saw when the server running our Angular application automatically refreshed and gave us the new content on the page without us touching the browser. In Visual Studio, we have a similar feature called Browser Link. Further down, you can see use static files like we had before, and now there's a routes map spa fallback route. So what this does is if somebody tries to browse to our application and they're using an address trying to go somewhere that was generated by the Angular application, and that location doesn't exist with a controller that doesn't exist server-side by MVC, we're going to tell it, you know what, just go to the home controller's index action by default. So let's look at our home controller. And our home controller is very, very simple with an index and an error method. Well, that's kind of boring. Let's keep going here and see what else is going on. Let's look at the views for that index method. So I'll go down into home, and there's index. And now this is using a layout, and I've got this app ASP pre-render module bit here. Client app dist main server. Well, this looks like an Angular directive. And if we take a look at our layout, so my layout looks even simpler than we had before. We don't have the environments and things that we are typically seeing when we have our layout in a full ASP.NET application. Very simple with a call to render body and a render section for scripts at the bottom. So my index is going to push main client JS from the dist folder down onto the footer of the page. So where's the dist folder? There it is. And if we look at that, you can see there's already some content that's been deployed here. This is because in the background, just as when we're working with a normal ASP.NET Core application that doesn't have Angular or the SPA frameworks hooked up to it, it's compiling in the background and it's laying down content on disk for us as Webpack is done churning through it and building. So we've already got main client JS sitting here. And we've already got a vendor JS with all of our vendor contents deployed for us. And even an image that's sitting here. So let's look at what's in client app, and this is where the Angular application is living. So I can open up the app, and there's my app module TS. The entry point for all Angular applications is right here. And you can see it's importing a bunch of different components. It's bringing in our router that's going to run client side and allow us to set different locations to navigate to and which components to load. And you can see the router is configured down here on line 21. When these paths are requested, it's going to redirect to, well, home, which will load up this component instead. And here's a wildcard at the bottom. If anything that isn't specified above is requested, redirect to home and bring up the home component. If we navigate to counter, we're going to find the counter component. And if we navigate to fetch-data, we'll go to the fetch data component. And you can see those components are defined right here under components. And then there's home, fetch data, and counter. So let's take a look at the components folder. There's app, counter, fetch data, home, and nav menu. Well, what's the app one here? Because this bootstrap statement here is indicating we're going to start with the app component. If we look at the app component, it has app component.html, and it's this very simple layout, which actually looks like it's using bootstrap syntax. Let me go back to app module. You can see it's bringing in app component. Where's that app component living? It's actually been nested by Visual Studio underneath of this because Visual Studio understands that these three objects are related. So let's look at the app component TS. And you can see it's going to select the app tag, use app component HTML, use the app component CSS, and it doesn't have anything it's really going to pass into that. So this HTML, it's actually going to start resolving the contents of this and go figure out where to put these things. So nav menu is included in my app module as a declaration here. It's being included. It's one of the components that's available in my application. So because it's been included and it's been referenced inside of this HTML, it's going to come down and it's going to include this HTML because this TypeScript says that the nav menu tag renders this HTML. And it's a simple menu. Okay, that's fine. There's some CSS to go along with it. Okay, that's pretty cool. So we've got these various components that live here, and these are going to be compiled, and they're all being delivered into this main client JS. So look at how big this thing is, and this is all the code that was written in TypeScript compiled up and made very simple for Angular to transport back and forth to the browser. That's pretty cool. Let's actually run this and see what happens. So I'm going to start this on the command line, and this is the result that we see when we actually get the web page loaded. Now, this is a little bit different from our normal default application. As we saw, we've got a nice bar over here that shows us the various locations we can go. In this sample, this is just showing us some of the things we can do. But what's interesting is, if we look at the source code to this is completely rendered content of what was inside that app component. It completely rendered our first request. Watch, I'll refresh the page. And you don't actually see that flash that you're used to seeing. I'm even going to do a Control-R, and we don't see that flash that you get while it's still loading data for an Angular application. It's because it's using Node embedded inside ASP.NET Core to render this JavaScript as HTML and then serving that for us. So I can click through into my counter here, and if we look back inside Visual Studio, go back into our client app, and into the app folder here we had components. Here's our counter, and it had a very simple HTML component, right, with a mustache here with some value, current count, that it's pulling out of our module. Let's take a look at the module for this. Here's our TypeScript. Let's put this vertically next to our HTML. So we've declared a component using that attribute, and then it's exporting that class, counter component, and it's got a public property called current count. And that property is being consumed right here. If you're used to seeing, or if you're familiar with seeing the old ASP.NET web forms, where you could put properties from your code behind directly into your resultant HTML by just wrapping it with a little bit of markup, you're seeing the exact same behavior here. I have this property that is being output right here. But this is all being done client side. So I have a constructor here. I'm sorry, this isn't a constructor. It looks like a constructor, but it's actually a method. It's a public method called increment counter. And this click directive is saying bind the click event to this JavaScript method. So the click event of this button that has the word increment on it will fire this JavaScript method and increment the current count of this property. So this will be updated automatically on our page. Let's go back to our browser. There's my increment button, and it just increments, and I see that interaction with my JavaScript objects. Now there's another sample here called fetch data. Let's look at this one. Now you saw it had a quick loading thing, and then it brought back data in this nice table format. Let's look at it again. Okay, so what's happening here, if we look at the fetch data component, so here's fetch data, and I'll bring out the TypeScript to go along with it, and let's put those side by side. So here we have the weather forecast. This component demonstrates fetching data from the server. So this is the TypeScript that's going to define how we interact with that. So we have a paragraph star ng if. So this indicates, the star indicates this directive is going to change the structure of the application. Watch it. And if not forecasts. So inside of my class that's being defined here, I have a public object called forecasts. So if this object is empty, it's going to show loading. Now in my constructor for the fetch data component, you see here it's going to receive an HTTP client that's defined up here in the Angular HTTP module. And it's going to go get API sample data weather forecasts, subscribe to that, and the result of that request, it's going to push into this .forecast. So this property, take that results in JSON format and cast it into a weather forecast array. And our weather forecast object looks like this. Now, we'll look at where this is coming from in just a second, but this weather forecast object that's coming back is used here in our table. And once again, we have that star ng syntax indicating we're going to change the structure of our application output here. And we're going to use a for loop. So we're going to use a standard JavaScript let statement. Let forecast of forecasts. So we know forecasts is this property over here in our class. And we're going to grab each one of those and we're going to call it a forecast. And we're going to output very easily in each one of these columns the forecast and a property of it. Now let me go over here. So this is pulling from API sample data. Well, we have a controller here called sample data. And it's just getting that weather forecasts action. And it's just going to return a new weather forecast object and some very simple summary information. But check this out. Here's the actual weather forecast class. And look, it's got a date formatted object, a temperature in Celsius, a temperature in Fahrenheit. That's actually a property that's calculated using that Celsius to Fahrenheit calculation, and then a summary. So that's pretty simple. It's just a random collection of these values that it's generating and it's returning with my HTTP GET. So fetch data is using this to connect to and get data and present it on the screen. So we should be able to do something similar here with our hats object and our hats collection. So I'll stop this and I'm going to bring over into my controllers that hats controller that I built earlier. And I'll also add a models and add in our hat model. There we go. And my hats controller. All right. So now let's write our own component called hats. So I will add a new folder and I'll call it hats. And we'll make this run very similar to our fetch data. So we'll have a new item that we'll add. This will be an HTML file. There we go. And we will call this hats.component.html. And we'll add a TypeScript file with that. There it is. And we will name it hats.component.ts. There we go. Now, before we do anything here, we need to make sure that our application knows about it. So over here, I will open the app module, and I will import our new hats component. And Visual Studio is helping us along the way. There we go. And I'll add to my list of declarations here, hats component. Now, of course, we need to be able to navigate to our hats component. So let's go down into our router and let's add a route that knows how to navigate to our hats component. So we're going to specify a path, and let's just make our path very simply hats. And the component we're going to load is, of course, hats component. So now we have a router that defines how we get to the hats location. We actually now need to give you a link to get you to the hats location. And for that, we'll go over into the nav menu and we'll add an entry onto our menu for that. So here in the nav menu component HTML, I'm going to scroll down to the bottom here, and you can see these are a set of list items with this router link active directive sitting on top of it. This directive, router link active, is going to check to see if there's an anchor inside of this tag. And if it is active, we're going to assign this class to this LI. And the router link here says that we're going to generate a href for this A that points to the fetch data path as defined inside of our Angular router. And then we have regular HTML content after that. So let's do it. Let's add one here for our hats. So I'll generate an LI, and inside of this, we're going to add router link active equals, and we want it to be the same thing, and that is link-active. And now we need our router link. And this is going to, of course, go to /hats. All right. And let me lay out that span. And it is a glyph icon. And I will also use the glyph icon apple. And we'll put the word hats. All right, I think that does it. Let's build out our module for our hats component. And I'll actually start with the content of my fetch data here because this is really close to what we want to do. And I'll paste that in. And let's change where I'm going and fetching the data so that I'm going to API hats. And because it's a web API, we're doing a get method here off of our HTTP object. So it's doing an HTTP get action, and that'll trigger that get method in our web API and return a collection of hats. Next, let's make sure we change this from a weather forecast to a collection of hat objects, and we need to define what a hat is. Of course, it has an ID that's a number. We don't have an int. We have a number and we have string. We have a name, and our name is a string. We have a count, that is a number, and we have a color. And we need to change this from forecasts to hats. And this is a hat object. And we'll return this as hats. Let's not forget to make sure we specify the information about our component here. This is hats, And our HTML is hats component HTML. Let's try and run this and see what we get. And there we go. Here's my hat collection with a little apple glyph. If I click that, nothing returns. Let's do a hard refresh. So why didn't I get any content over here? Let's go back to Visual Studio. And it's referring now to the hats component HTML template. Let's take a look, and you can see it's not doing anything. It's a ugly HTML default template. Let's do something similar to what we did with fetch data, and let's make this just as simple over here for our hats. So we'll change this to say my hat collection. Here are my hats. If we don't have hats yet, we're loading. And here's what we're going to make this look like. So there's my ID, name, count, and color. Now, I've saved that, and this is actually going to do that hot update for us. And look, I can actually have a breakpoint hit here inside my API controller. I'll let that go through. And if I go back over to my browser, I've got my data loading properly for me right here. That's pretty cool. Let me go back and let's tune my hats component. Let's not just make it a table. Let's make it a table with hover capabilities. Save that. I'll turn off this breakpoint in my ASP.NET. And if I look at my application here, I now have hover capabilities. Let's do one more change here. I'm going to go back over and inside of my TypeScript. So now we'll do one more thing here. I can actually set a breakpoint here on my get. And in fact, I don't even care so much about the get call. I care about the result. And I can change this to go use web browser Internet Explorer. And with the new feature in Visual Studio 2017, I can actually hit this debug point in the middle of my TypeScript. And let me also turn on the debug point over here for the fetch on the API. So now if I start this, it's going to start up my application just like it did before. And now my application is loaded in Internet Explorer. All right. Let's take a look at that hat collection this time. So now I've clicked on hats collection, and I'm in the middle of my API. I'm in the middle of my ASP.NET code where we're going to return that collection of hats. I'll click continue. And I've jumped out. Now I'm in my TypeScript for my hats component, and I've stopped here where it's received the results. And take a look down here. Inside my locals, I can actually look at the contents of that result. Here's the body of it and the status. And I can see that it was marked OK. So if I continue from here, it finishes running, and I can see the results in Internet Explorer. Now this feature will also work with Google Chrome, but this is Microsoft Visual Studio giving the ability to debug server-side and client-side together in the same application. That's pretty cool. All right, so we've learned a lot about how to use Angular with ASP.NET Core. Let's go take a look at some resources so we can learn a little bit more about Angular and we can learn a little bit more about ASP.NET Core. So we have these resources for you. You can go get ASP.NET Core from .NET, and you can get Angular and more information about Angular at angular.io. I have two other videos for you to check out about Angular on Wintellect Now. Jeremy Lickness has a course called Introduction to Angular 2. I recommend you check that out if you want to go deeper into the Angular functionality that we just touched the surface of here. And TypeScript Once again, we barely touched the surface. We got just enough information to get us up and running. Well, Mitch Harper has a great course out there for you on Wintellect Now called TypeScript Essentially, JavaScript Eventually. Hey, I've got a bunch of other courses on Wintellect Now about ASP.NET Core. I hope you check them out.